Yay, it worked. All right. Good, good, good. Well, welcome to one of you who's made it in. We'll give a few minutes here while everyone else gets a chance to uh, reestablish their link. Not sure what happened. I've done enough of these. For some reason, it got to the place where it was going live and it was just spinning and spinning and spinning and never doing what it told me it was going to do, never really going live. But now we're going. So with that said, type your questions in the chat box. We'll cover what needs to be covered today. Make sure I sent this to everyone while we're still waiting. Yeah, that was sent to basic algebra. Oops, afternoon section. Yep. And let's double check on the other one. Sent email. Yep, it was sent to the first section as well. So we're set. After a short delay. Can we go over problem number 7? Are you referring to the review set, Aaron? I haven't had a chance to look at this for a little while. I put it together over the weekend. Marginal cost, sure. Let's go over that, shall we? So that's a good one to look at. Yeah, question 6. Yeah, all these are on the review packet. Yeah, all right. So I'm already turned to problem 7. So let's start there. So we're given the marginal cost. And I can graph that marginal cost if I'm wanting to. It looks something like that. Decreasing function marginal costs are always. So these are measured in dollars per unit manufactured. And these are the number of units manufactured. So again, that curve, it gives us the marginal cost, how much it costs to produce the next unit is just about what that means. Then this is as the number of units change, that marginal cost changes a little bit as well. It's really high in the beginning. When you go from 1 unit to 2 units, you save a bunch of money. That's why it's so steeply negative here, and then it flattens out going from 100 to 101. You're not going to save that much, or the cost isn't going to be going down quite as much as you get out there toward capacity. So how much will it cost to increase production from 50 to 75 crates? So notice how much it costs. That's going to be units of dollars. And there are no dollars here by themselves. But note that if you multiply these units together, I guess these are dollars per crate. Well, you can do it, make more sense. Dollars per crate, and these are the number of crates produced. That way I'm not using the word units more than once. So the area under the curve, that's going to be the number of dollars that what's going to cost us. The area under the curve. So we're looking at how much is it going to cost to increase from 50 units up to 75 units. It would be this area under the curve. So one more time, and this is the big takeaway. If you want to do well on this next test, you have to understand how a definite integral works and how the units work on this. So the area under the curve is always going to be measuring whatever these units are. These were dollars per crate, multiplied by whatever those units are. Those units are crates, and since those cross cancel, one in the numerator, one in the denominator, you're just left with dollars. So anything under here is going to be measuring dollars. From 50 to 75 would be this area under there. That's that cost in dollars it's going to go to move production from 50 to 75. So we can find out what that area is under the curve by coming up with this definite integral. So my function here is 125 e to the negative 0.025x. And we'll go from there. Let's see, the antiderivative. It's 125 is our constant multiplier. This one, I better put a dx at the end just to be absolutely correct. This one is one we've seen a lot. Remember that we're going to keep that e to that same power, whether taking a derivative or taking an antiderivative, e to the negative 0.025x. If we were taking the derivative, we would have multiplied this by negative 0.025. Since we're taking the antiderivative, we'll multiply it by the reciprocal of that. And I like to keep my negative signs out front if I can, okay? So if you'd like to work all the way through this, and what the heck, some people have been struggling a little bit with their calculators. First off, someone with their calculator do that so that we don't have a whole bunch of messy stuff going on. I think this is, get the decimals right, 1, 2, 1 would be a quarter. I think that's negative 5,000 e to the negative 0.025x. So someone with the calculator, double check that for me, please. And if that's right, then we'll be able to evaluate that at 75, evaluate it at 50, and do the subtraction. So let's work that all the way through if we could, huh? Negative 5,000, excellent. Okay, so that was right. So someone plug in 75, someone plug in 50. We'll see what we get when we get those two, and then we'll subtract the one from the other. I have my subtraction ready to go. So if someone wants to work on the first half and someone on the second half, so when you answer in the chat, say plug in 75, got that, plug in 50, got that. And while you're doing that, I'm going to look ahead, see what the next part does. Oh, yeah. Okay, negative 1432.5. Good. That's definitely going to be negative. It's got to be a smaller number. I can see that already. Negative 766 points. We'll round up. Negative 766.8. Subtracting a negative is adding, so it looks like we have 14,325 minus 766.8. That's going to be 600 and some. And my mental math isn't quite good enough, so someone do that subtraction if you'd be so kind. $665.75, yeah. So there's that one. This, I guess, units would be dollars. That's how much it's going to cost extra. And I want to make double sure here that my units are right, measured in dollars per unit. Okay, so find the monthly fixed cost. If the monthly fixed cost is $400,000, find the total monthly cost function. So to find the monthly cost, we already have taken the antiderivative. So we know the antiderivative, C, is going to equal negative 5,000 e to the negative 0.025x. We'll go with this. We'll write that as C of x. And then there's some number at the end. And I'm going to call this K in this case because I've already used the C. Now, what we should be able to do is, given this initial condition, the fixed cost is what it costs to produce 0 units. So if I plug in 0 here, the total cost should be $400,000. So $400,000 is equal to negative 5,000 e to the negative 0.025 times 0 plus k. E to the 0th power, any number to the 0th power is 1. So this is 5,000. If I subtract, or if I add 5,000 to both sides, this becomes 405,000. That's what the value of k is. So now I have the function that answers this question. Circle it here. Plus 405,000. Now remember, that does two things, and here's how I check my work on this one. The marginal cost should have been this thing I started with, and if I take the derivative of my cost function, I sure enough get 125 e to the 0.025x. And the other thing that's important is when I plug in 0, I should get 400,000. So if I plug in 0 here, this becomes negative 5,000 plus 405,000 is indeed the $400,000 that the marginal, or that the flat cost was. So there's part B. Use this function to find the total cost of producing 75 crates. All right. If someone wants to do the work ahead, and I'll put the answer up here, we'll make sure it makes sense. What's the total cost going to be if we produce 75 crates? Negative 5,000 e to the negative 0.025. Times 75 plus 405,000. Someone tell me what that is, if you'd be so kind. And I think that's it, isn't it? Oh, I thought there's another part. So that's how we'll figure that out. We have the cost function. We can use that cost function to answer anything. So as soon as someone puts a number up here, it's got to be quite a bit. It's got to be well over 400,000. 404,232. Okay. 233. Like it. Problem done. The other one was problem 6. Matthew requested 6, so we'll back up one. Another excellent one to look at. This is awfully close to the car production problem we did a couple of activities ago. As time goes by, our manufacturing process becomes more efficient. We make some changes here or there. System runs more like a well-oiled machine, and we end up having our production rate increase. These numbers are a little small. Let's see if I can make this a little bigger. Yeah. Okay, 8,000 is that. Okay. So production rate boxes per month. And then the number of months. This production rate is this curve. Here I have it in black, you have it in blue. That tells you how quickly you're manufacturing boxes. And the area under the curve will be the number of boxes produced, because it will be this unit times that unit. So anything regarding the curve will be the rate. This is the rate, production rate. And it will be measured in boxes per month. And the area under the curve will measure the boxes. So part A, estimate the production rate at the start of the 5th month. Well, if I read up from 5, so what we do is 5, if I estimate that and read over, let's see, there's 6,000, there's 8,000, maybe 7,200, get the units on this, boxes per month. There's part A, huh? The start of the 5th. Oh, the start of the 5th month. Oops, I messed up. Caught myself. 0, that's the start of the 5th month. 1 is the start of the 2nd month. 2 is the start of the 3rd month. 3 is the start of the 4th month. 4 is the start of the 5th month. 5 is the start of the 6th month. I better back up a little bit. Read that one wrong. All right, back here we go. So there's the start of